Hello everybody and welcome back. In my last few videos I was complaining a lot about cheap extruders and how they're such a pain to get to work. And because I've done that at least once now, I thought it would be interesting to show you what you have to do to one of these extruders to get them working. And the one I'm going to start with, or that I'm going to show this off, is this really cheap extruder from Amazon. This one cost around 20 euros and it doesn't even look bad. I mean, it's shiny and golden, it has everything that you need. It's got a 12-volt heater with 40 watts. It has a 100K temperature probe. It's 0.4 millimeters. You would think that this is really good, but unfortunately it's not. But with a bit of time and effort, these can be made to work, and when they work, they aren't all that bad. So let's have at it and let's see what is wrong with this thing and how we can fix it. So first we're going to start taking it apart, and I can already see that this one is busted. The fan seemingly got a bit force and the plastic is coming apart. But it's not going to be an issue. That's not going to keep it from working. So let's have a look at what this is and how it works. To start out, this is where the filament is fed in. There's a gear in here. There's a bearing and a holder that is supposed to transport the filament down. All these things. There's a spring in here that presses it back up again. And if you, for a start, look in here, you can already see that I can hardly move the lever because this screw is going in so far that it is actually pressing against the screw coming from above. That makes it impossible to get the lever all the way down. And this screw down here is in here so loosely that the vibration from the fan is going to remove it. So we're going to put that in with a bit of loctite later on. But let's start taking it apart. The fan is held on with 2 screws, and these screws with the last one that I got are so short that if you leave the fan protector on, you can't get anything in between here. This is not going to come off in a way that you can put an extruder mount in between here where it's supposed to go. So these screws are much too short. Fortunately, if you leave off the protector, then these screws will be all right, but you won't have any fan protector. That's not bad. The second problem is this cooler here. Now, this cooler has this coating on it, and there's a very nice video from Big Clive where he's showing off a diamond tester, and what he finds out is that this coating here is absolute rubbish. If you want the heat to go from this block into this cooler, there should not be anything in between here. No coating, no nothing. So what we're going to do later is we're going to take a file and some sandpaper and we're going to remove that until it is perfectly flat, because that is point 2. With these 2 drill holes in here, this is not going to be flat anymore because it was drilled, and as it was drilled, material was deposited right around the drill holes. We're going to see that. The next thing that is a problem is this wheel here. that is supposed to press the filament against the gear. It's not moving at all. Not the tiniest bit. So if we unscrew this just a little bit, it still won't move. So I suppose this one's busted. Let's remove this. And there's actually a bearing in here. And this bearing is working. So maybe we need to place a few washers in between here. Let's see. Let's put this back in. And all of a sudden it's moving. So you have to make sure that all these parts are moving. Right. Let's continue. Let's see if we can get this off. No. So we need a small spanner, about 10 millimeters. And if you look in here closely, you can see that the throat coming from the hot end to where the extruder is, where the drive is, and where the heat is supposed to be removed, this is in all the way. That's not optimal, because if you use flexible filaments or soft filaments or nylon, for example, you want this to be in about this far, so it doesn't actually have the chance to escape the throat, because that's what's going to happen. It's just going to go past it, and it's going to be collected in here, and it's not going to work. But if you screw it in this far, it will work. This brings us to another problem, and that one is really... Oh, come on. If we look at this throat here, you can see the PTFE tube up here. This means that this throat is mounted upside down. The PTFE should be down on the bottom. Now how do we get this off? We need a 1/4 inch spanner. We need to loosen this here. And now we can remove the throat. And if you look at the throat on the other side, you can see it's metal. And you want this metal to be on top next to the gear. That's the next thing. So all in all, maybe not a bad extruder, but it's definitely mounted completely wrong. And this was also the case with the other one that I got for my own 3D printer. And with that one, it was even worse, because these cables that came with it were like 30 centimeters. I think that these are longer. Let's see. Oh yeah. That is at least 80 centimeters. So, better. Okay, so next thing, we need to take this one further apart. And already the gear is already wedged in place and won't move. That is not good. So we're gonna have to fix that too. So to show this a bit better, I removed the spring, and you can actually see how close this screw and this screw here are. So at this configuration, you can't really press on the hold release button, because it won't work anymore. And if you use this screw to tighten down the spring so you have more load on here, it's not going to move at all. Instead, this screw, is going to press down on that one, and it's just going to wedge all of the filament in between these two parts, which is of course not what you want. So we're going to have to make sure that this screw doesn't come out when it's not all the way in by using some Loctite or super glue. And we also have to make sure that if this presses down and if you push this screw in further, that we don't get these two to touch. So yeah, that is that's a really big shortcoming. Now, taking this thing apart, it is rather funny to note that you need two of everything. There are two different sizes of hex wrenches. There are two different sizes of Allen wrenches, and you need two different sizes of screwdrivers. I don't know why, but I think it's kind of funny. Now, if we remove the lever, we find another screw down here. This one can be opened with a slightly larger screwdriver, and I don't know if you can see this, it is also so short that you are not going to get a mount in between here. So what you're definitely going to need is a replacement for this M3 screw, because that is like just barely holding on to one thread, and it's not 2.5 or 3 millimeters as your mount is going to be. So I don't know who thought of this, but he didn't spend a lot of time doing that. Also, the gear on the motor needs to be moved upwards at least 2 to 3 millimeters according to the thickness of the mount that you're going to use. Yeah, and for that you're going to need a third size of hex wrench. But yeah, everyone has that. Alright, so now that everything is taken apart, what we're going to do is we're going to remove the gold coating here, and we're going to remove the gold coating on the lowest about 11 to 13 millimeters of this cooler. By that we're going to get a better connection between the cooler and the body and the cooler. And also, if you can see, there is gold coating in the where the screw is, where the throat is going in. So we can't do anything about that, but at least we can make sure that the heat from the heater does not get dissipated by the motor, because that is getting hot by itself, and we can make sure that this cooler here works as desired. So to get the coating off of these two parts, we do need a bit of sandpaper and some wood to put this on. And the way I like to do it for this cooler is to just place the cooler over the sandpaper at the point where you want to remove the coating, and just gently start scrubbing it off. You can actually see that this surface isn't flat at all, so this is going to take some time, and you're going to see how uneven the surface is and how little contact it is making with the base. After we're done with this is going to be a lot better. So already you can see the places where the drill holes are actually higher than the middle of the cooler, but that was to be expected. Yeah, this is going to take some time, I think. As you can see, this is not coming off very evenly, but it does look a lot better after that. So as you can see, we're slowly getting there. You can actually see that there was quite a bend in this cooler. We can also use straight edge to check if it is flat now. And yes, it is. And this looks very promising. So, about 10 minutes later, this is where we are now. We now have about the thickness of the body with exposed aluminium, and exposed aluminium has the best heat transfer capability, a lot better than the coated one. And you can also see that the aluminium wasn't even flat to begin with. So this is about good enough. I'm going to give it maybe another minute, and then I'm going to start grinding down this bit here. And after that, I'll check both surfaces with a straight edge, that they're flat, and then we can basically put them back together, and the heat conductivity between these two parts will be a lot better than before. So this is the finished thing, number one. Now we start with this here. You can also see that this is not flat either. And you can also see that this coating on here is actually not anything put on electrically, but it looks like some fine layer of paint, which is really bad, you know. If you ever get the feeling that the aluminium is not running smoothly over your sandpaper, this is a 1000 grain sandpaper, I believe. Let's have a look. Right. Ah, no. This here is a 400 grain sandpaper. And if it's not running over that well, just move to a different spot and continue from there, because you don't want to have any big grains under there. And you can also just gently clean that off and start over. So we're almost there. It's a lot easier to remove this paint than it is to remove the luxation. Now, the further I go, the more it becomes apparent that this body has one big dent right in the middle. If these two had been joined up, there would literally have been no heat dissipated from one to another, because they would only be in contact right on the outside and maybe a little way in and through the screws. So that's the reason why we're doing this. We want to have these two pieces make really good contact over a really large area. Okay, this here is done. This here is also done. I checked both surfaces with a straight edge to make sure that they're flat, because if you need to be a bit careful when you're sanding this down that you don't accidentally create a hump on here, because the aluminium comes off better at the edges than it does in the middle. So you have to be really careful. You have to take your time. You have to go a bit in circles or change the direction going forward and backward, so that doesn't happen. Now I'm pretty happy with this. I'm also pretty happy with this one. They both look really good. I'm going to clean them off now, and then these two parts are done. The only thing that we have to do is we have to put some Loctite on this screw. So now that everything's cleaned off and flat and the way we want it, it's almost time to put it back together again. The screw that was on the top part of the extruder, the small one, I will replace it with a slightly larger one. That is an M3 screw. When we're putting it back together, we're going to make sure that the metal part of the throat is on the upper side and the PTFE is on the lower side. And the last thing to do is we need to move the gear on the stepper up by about 2 millimeters if the thickness of our mount is 2 millimeters. So if we have a mount that is 3 millimeters, we need to move it up 3 millimeters, of course. And I'm going to do this before putting it back together, because it's pretty hard to get in there. And surprise, one of the screws wasn't tightened down. Why am I not surprised? By the way, for this thing here, I measured the stepper, and the stepper has a resistance of 2.1 ohms, which will put it around the 2.7 to 3.5 volt range. And that stepper isn't really bad, but it isn't the one they advertised. But it works. Okay, now we're gonna put it back together, and when we mount these two parts, and when we mount the throat, we are going to put a little bit of heat conducting silicone on here and in here, so we can make sure that we have a very good heat dissipation into the mount and into the cooler. But just a little bit. Right. To show this off, I don't have a mount right now. I just realized that. So I'm going to put it back together without the mount. Usually the mount will go in between the stepper and the main part here. So first thing is we need the slightly larger screw. I hope that it's not too large now, but let's find out. Yeah, it's a bit too large. Once fastened down, it has exactly 2 millimeters of play, which makes it the right length. But just for showing this here, I am going to use the original one. Then this is going to go in here, just to get the length. We have to make sure that the idler and the drive gear don't touch, but we can make it get real close to that. It shouldn't be touching, but it can be like 0.5 millimeter up to there. That is the point that we're trying to get. That makes sure that if we use a flexible filament, it is not going to bend and get behind the gear. But this looks very nice. I'm going to use this length. When we have it here, we're going to remove it again and add the heat compound. Which is here. So let's get a bit of heat transfer silicone. And this little bit is already enough. So to work it in there, screwing the screw in and out a couple of times. And the distance from the throat to the idler is about 0.5 millimeter to 1 millimeter. And once I have all that set up correctly, we tighten this down. And that's it. So for the next step, we're going to take this screw out, and that's where we need the other hex wrench. And for that, we are going to use a very small amount of Loctite or other screw holding glue. So if we only, there we go, if we only screw this in halfway, it's not going to be an issue, it's not going to fall out. It doesn't need to be in all the way. So that little bit is already alright. We need to add the spring. And then we're going to apply a little bit more heat conducting silicone up here, but very gently, only a small amount. We spread it out. And then we're ready to mount the fan. Now when we mount the fan, we need to make sure that if we have the extruder mount on here and we tighten down the screws, we need to make sure that the screws do apply a reasonable amount of pressure to the cooler, because they will actually cause everything to get a really good contact and to have a good heat transmission. Also, it makes sure that the upper part here has a small gap in between, so the lever works. If you're tightening this down and you notice that your cooler is in contact with the lever, then something's wrong, and you should possibly change the angle of either the mount or the cooler so that doesn't happen. This is really important, because if these two touch, then that connection down here can't be good. Now, since I don't have the extruder mount installed, and I'm not installing it on a 3D printer, I'm not going to tighten this down very, very hard, just to show how this needs to go in here. And once we're done with that, we can mount the heating element and the nozzle. Now, I don't really like these nozzles all that much. I much rather prefer the flat type, like the one that is on here, because it just has a little bit less of distance and more mass very close to the nozzle. These usually work very well, and they're also really cheap. But that just on the side. Now, I am going to mount this one at approximately the right distance, and when you mount these, you want to make sure that you have the heating element and the cable going off to the back of the extruder. So if this is your axis, you're mounting it on here, you want the cable to go in this direction or that direction, not toward the front. Also, you want to make sure that if you have another fan that you're placing there, the fan needs to blow around it. That is quite important. So I'm going to try and mount this like here. I don't know if I have enough threads left, so let's try. Yeah, that feels good. And once I have this all lined up the way I want it, I just tighten down the nozzle very gently, making sure not to move the heating element, making sure that the screw holding it to the mount does not turn. Now once you're done with that, you're done putting the extruder back together. You should make sure that the nozzle is on tight, but don't overdo it, because you can actually break the brass from the nozzle, or you can break the top of the throat, and then the nozzle will leak to the upper or the lower side of the heating block. And if that happens, you're usually in trouble and you need to replace the throat or the nozzle or both. Or if you have a really bad heating element, the thread in the heating element is slightly too large, and that can also cause a bit of leakage. But apart from that, this is already in. This is everything that I did to my other extruder to turn it from almost not working at all to pretty good. In fact, it's really good. It is so good that I'm really thinking of maybe just leaving it on my other 3D printer. And at between 20 and 25 euros, the price is okay too. It takes about, well, half an hour to 1 hour to do the modifications, and when you're done with that, you still have to basically get it running on the printer, but it's worth the time. It really is. because it just turns this thing from a piece of junk to something that's really working. Thank you very much for watching, and bye bye.